Hey guys, now we're going to look at covalent bonds. So covalent bonds are bonds that are created with two nonmetals. That means that we are sticking to that top right triangle on the periodic table. Remember, noble gases, column 18, will not bond with other elements. So we're just looking from column about 13 to 17 in that top right corner. Electrons in these types of bonds are completely shared. Each element has a strong enough pull that this ends up being like a tug of war, and the electrons kind of go in between both elements, whether it's around one twice and around one once. Either way, they are being shared and they are spending time with both elements. These tend to be weaker bonds. They are gases at room temperature, and they have very low melting and boiling points. When we draw these, we are going to draw these with circles, which we are then going to replace with lines. So again, we have about 3 steps to draw covalent bonds. The first step is the same as the ionic bonds. You draw the Lewis dot diagram for each element. The second step, you draw a circle around newly paired electrons of both elements. Now, circle, you could also call it an oval because sometimes it will look more ovally. Then we will replace those circles with a line. Remember, you must redraw all non-shared electrons around the original symbols. I want to be able to see how many electrons are there. So you can count the electrons individually, and then each line represents an extra 2 electrons. So we're going to try this out with hydrogen and oxygen. Hydrogen has a single valence electron, and oxygen has 6. So I'm going to draw an oval connecting these 2 circles. So hydrogen's in that first row. That means that he only wants 2 valence electrons to be happy. So he has this one from himself and this one from oxygen are now going to be going around hydrogen and around oxygen and back around hydrogen and back around oxygen. But oxygen does not have 8 electrons yet. He has 1, 2, 3, 4, 5, 6, 7. So we have to draw another hydrogen with another valence electron and a new oval. Now I'm going to redraw that drawing. Hydrogen with a line connecting to oxygen. Oxygen has 4 valence electrons still, and another line connecting to another hydrogen. So notice I did not put any dots around hydrogen because these 2 electrons are now being paired together. So this hydrogen has a line, that's 2 electrons. This hydrogen has a line, that's 2 electrons. And this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So they are all now stable. Just like last time, we are always going to write the chemical formula. So this one would be H2O, and we are going to write the chemical name. Now the chemical name I don't want to get to quite yet until you see the notes on the next few slides. Those tend to get a little bit more interesting because it's not just adding an IDE anymore. Okay, so one more thing that I want to show you. If you were to draw this, that is not the same drawing as the one that I added here. This is showing that I have a double bond between 1 hydrogen and 1 oxygen. But since there are 2 hydrogens present, I do need to have 2 H's present in the next drawing. So be careful when you're doing this because you don't want to take a shortcut and assume that you're still correct because this drawing is not accurate. So writing the formula, remember it's super easy. Count the number of each element, write the symbol of the first nonmetal with a subscript to show how many are present. Write the symbol of the second nonmetal with a subscript to show how many are present. And remember, you do not need to place a 1 if there is only 1. Having it listed already does that for you. Now, writing the name gets a little bit interesting. The first nonmetal's ending does not change at all, just like with the ionics, and they stayed the same completely. But we do have to add a prefix. If there is any number next to the first nonmetal, 2 through 15, you have to add a prefix that corresponds to that number. So the last example, we had 2 hydrogens, so we would add the prefix dihydrogen. But if you only have 1 of that element, a prefix is not needed. The second nonmetal's name changes the most. Just like last time, you are crossing off the ending and replacing it with an IDE. But in addition to that, you are also adding the prefix. Here's the tricky part. The second word needs a prefix every single time. It doesn't matter if there's 1, it doesn't matter if there's 7, it needs a prefix every time. The first word gets a prefix as long as there's more than 1. So we're going to try this with carbon and oxygen. So carbon has 4 valence electrons, oxygen has 6. I'm going to draw my oval and draw my second oval. So this oxygen is now happy. Carbon still has 2 valence electrons that he needs to pair up. So I'm going to draw a second oxygen to the left. Now I'm going to kind of mirror image this one. I'm going to put my paired electrons on the bottom and on the left, and my singles on the top and on the right. That way my circles are shorter and they're a lot easier to see. Now I'm going to redraw this. Oxygen with 4 valence electrons unpaired, and I have 2 circles connecting it to carbon. That means I need 2 lines connecting it to carbon. This oxygen, again, has 4 valence electrons unshared, and 2 circles connecting it to carbon, so I need 2 lines connecting it to carbon. Now I'm going to write the chemical formula, CO2, and we're going to write the name. So the first word does not change, but I'm going to put a little line out front to remind me I might need a prefix. Second word, we change the ending to IDE, so oxygen becomes oxide, and I'm going to add a line because I'm going to need a prefix. So remember, the rules were the first word gets a prefix as long as there is more than 1 element. Since there's only 1 here, I do not need a prefix on that line, so I'm going to put a little X to remind myself. The second word always gets a prefix, so since there are 2, I'm going to add the prefix dioxide. Now on the test, I'm not going to make you remember prefixes, but most of them are really easy. If you don't know them, you can look them up, but we're not going to go past 10. So 1 is mono, 2 is di, 3 is tri, etc., etc. Now here's the catch. After we practice with covalent bonding only for a day or 2, next thing I'm going to do is start mixing things up. And once that happens, you will not be told which type of bond is occurring. You will have to determine it yourself. That means the first thing you need to look for, or the deciding factor, is there a metal? If your answer is yes, it is an ionic bond. If your answer is no, it is a covalent bond. And remember, ionic bonds, we use arrows, and there are no prefixes. Covalent bonds, we use ovals, and eventually lines, and there are prefixes. So, like I said, this first example, this first set of practices, they are going to be separate still, but once you get the hang of it, of looking at them separately, I am going to mix them together, so you have to determine, is this ionic or is this covalent? How am I drawing it, and how am I writing it? So I'll see you in class so we can practice with simple covalents, just covalents, without mixing them up, and then we'll take it a step farther.